Namaskar, my dear friends. So we have seen the details of PIC18F47Q10 device. What are the features? What is the capability of this particular microcontroller that we have? We have already seen complete design and techniques and the device details. Now we will directly try to implement this particular schematic. What are the power supplies? How we can interface different components. Let's say UART, SPI, all these things. So we'll see one by one. At the same time, let me tell you that this particular microcontroller is very robust, and it has real-time control and sensor nodes, and it has very broad range of applications like industrial, control, consumer, automotive, touch sensing, and Internet of Things as well. Okay. So our aim is to design the circuit with PIC18F47Q10 and 40 pin PD package. So our main device target is this one. Okay. So as we have already seen, this is our pin configuration. As you can see, pin is from pin number 1 to 20 and 21 to 40. So I will be making a symbol of 40 pins PD package, and it has 5 ports: port A, port B, port C, port D, and port E. Okay. Let me give you a high level of block diagram for the microcontroller that we are going to see here. So this is the microcontroller block, okay, and we have a power supply input. Let's say we have, let's say, 9 volt to 12 volt input, or even directly you can give 5 volt input also, because we are going to see a 5 volt application. Here it is power distribution network. So basically it will be having some LDOs, okay, so which will try to convert it to 5 volt, which will be a supply to the microcontroller. There are one more LDO which is used so that it can convert to a voltage 3.3 volt, which will be used for some other purposes. Okay. As you can see, some of the peripherals, let's say it has incorporated IR sensor interface, external interface is there, which will be, like driving some other board. There is ADC section, EEPROM interface is there, which will be using I2C interface. There is a buzzer, there is temperature sensors. Temperature sensor, 2-3 techniques are there. One is analog sensor, one is digital sensors, and all those things. We have dip switches, we have push buttons, we have LEDs. Then we have LCD interface as well. We have programming, how we can program this particular microcontroller. SPI interface, UART interface. UART interface can be taken for some general usage as well. Let's say UART to RS232 or UART to RS485, and UART to USB connections. Okay. So basically it is very useful. UART to USB bridges, they are basically used for your interfacing the microcontroller to the system, to the your like a personal computer or laptops. All right. So once we have seen that, so in series wise, what we can see is we can directly talk about each and every one of them. Let's say power supplies, and like programming and reset and everything. Okay. So what we'll do is we'll try to directly put into the microcontroller circuit. So what I have done for you guys is I have the PIC18F47Q10-I/P. So this is my 40 pin PD package. Okay. So as you can see, I have not changed the pin, like orientation. It is 1 to 20 and 21 to 40. Now, very first thing that you have to, like proceed for the microcontroller design, so that it doesn't, like get affected during your programming and working, is you have to connect your power supply. Let's say here it is VDD1 and VSS1, and this is VDD2 and VSS2. So you have to connect a bypass capacitor which was 0.1 microfarad, that was recommended by the microcontroller data sheet. Okay. So I have connected 0.1 microfarad, and VDD is our power supply. I have kept VDD so that, like even if I want to run this for 3.3 volt or 5 volt, I can keep the power supply to 5 volt or 3.3 volt. Okay. And I don't need to make any changes in the inside of the microcontroller design. Okay. So this is our main first one. Next one is we had to connect the reset circuit. So reset switch is this is the reset switch connected to my MCLR pin. Okay, so MCLR pin, you can see there is a reset button, and it is always useful to connect it to pull up. So this is pulled up with a 10 kilo ohm resistor, and actually it is recommended that you give one series resistor as well, So series resistor you have to connect here, let's say 470 ohm or less. Okay, so I will start with 470 ohm. So please make a change of 470 ohm series resistor to this particular line. Got it? This capacitor is always useful to connect zero point 0.1 microfarad, but sometimes what happens is when you are programming, this may not allow you to program. So at that time, what you can do is you can disconnect this capacitor, okay, and program this particular microcontroller through this programmer, okay. Otherwise, you can keep a provision of putting a jumper here, okay. So these two pins will act as a jumper, and whenever you have to program the microcontroller, you can remove the jumper, and whenever you have programmed already for normal working process, you can keep the jumper on. Okay, so this is the change that you can make. Why I have not made all these changes? Because I want to show it to you, like what are the improvements or what are the like reasons that you want to make these changes in your schematic. All right, so you have seen the bypass capacitor, like decoupling capacitor connection, then you have seen the reset switch connection. Now coming to the fact that we have to connect the programmer connector. So programmer pin, what happens is this is a PIC18 connector. So PIC18 is having 6 pin connector. Okay. So in circuit serial programming, that is ICSP programmer. Okay. So in that we have 6 pins. So pin number 1 is your MCLR pin, which is going to be your reset. Okay. Next is your power supply, then a third pin is your ground pin, and fourth pin is your ICSP data and ICSP clock. Understood? So ICSP data and ICSP clock, if you see, so in this, if you see ICSP clock and ICSP data, what happens is this ICSP data pin will be connected to pin number 40. You can see here this pin, and ICSP clock will be connected to your pin number 39. All right. Now coming to the fact that there are some of the basic requirements of this particular microcontroller, like pin number RA4. Okay, so RA4 pin number 6 is open drain pin. So for any open drain pin, if you want to utilize them as a output pin, okay, output, then you have to put it pulled up. So this is pulled up by default, so that you don't have to worry about that later on. Okay, so any open drain pin must be pulled up for making them use as a output pin. If you want to make them use as an input pin, then there is no need, but for output you have to put them pull up. One more thing I have done here is I have connected RF5 to a potentiometer. Okay, potentiometer. So this 10K potentiometer, as it moves up or down, based on that this particular voltage will reduce or increase. Okay, this node voltage. So this node voltage will be going to your RF5. So RF5 is connected here, and this is actually a having capability of ADC. So I have told you almost all the pins are having ADC functionality. So this RF5 will be acting as a ADC input, and this is how you can get your ADC value for the particular value of this particular voltage. Okay, so that's all. This much I have done. Rest all I have connected, like OSC1, OSC2, RC1, RC0, RC1, RC2. All these things I have connected, and I'll go all this section one by one. Okay. Now let me tell you power supply. So what happens is this VDD voltage which I was talking about. So you must have a power supply 5 volt to power the microcontroller. So for that, what are the functions I have given here? I have taken a 2-pin connector. So this is kind of a terminal which will be connected to the external power supply. So which will be called as VCC right now. So I have given a range of 9 volt to 12 volt, so that this IC is capable of giving the voltage output as 5 volt. So this is LM7805 CT slash NOPB. So this is very versatile very versatile LDO linear regulator, and this is very much useful. Okay, if you want, you can utilize pin to pin compatible other regulators as well. Let's say LM340. Okay, so if you want to see a complete part number, so this is LM340 80-5.0 slash NOPB. Okay, So this is the complete part number for your LM340 series. LM7805 series is also very useful. Another option what I have given is jack I have given. So you have lot of power adapters these days which will be giving you, you know, like a 6 volt or 9 volt output with 2 ampere current rating, or 12 volt output with 2 ampere current rating. So I will request you, or I will suggest you to put a you know, like a adapter with 12 volt 2 ampere rating, or even 1 ampere rating will be sufficient for this particular application. So this will get connected again back here, and that time you don't have to connect this power supply. Okay, any one of them is more than enough. And this particular LDO will again give you the output of VDD. Got it? One more thing what I have done is this VCC is directly connected through resistors. So this is 1206 package resistor, okay, which will be little bit higher rating, and directly going to get connected to VDD. Okay, so in that case what happens is this VCC, what happens sometimes is like you have a you know, like input coming from some other board or somewhere, and that is directly giving you a very filtered output with 5 volt. Okay, so that 5 volt you don't have to go through the all linear regulator or all these things, directly you can connect it to VDD. So for that I have bypassed. You can make D9 as not used that time, so you can remove this particular D9, and at that time VCC will be directly get connected to VDD through these two resistors. Okay, so these two resistors you mount it and you will be able to get your VDD. Now what I have done, one more you know, like option is this VDD, that 5 volt output is going to go through a linear regulator LDO. So this is very good regulator which is capable of giving you 3.3 volt output. Okay, so it has the capability of 300 milliampere, which will be used for a lot of other, you know, like analog peripherals functionalities. All right, so this is 5 to 3.3 volt linear regulator. So we are now ready with our power supply. We are ready with our, you know, like reset switch, our programming connector, and a small, you know, like ADC connector. We are always, you know, like ready with already our bypass capacitors to the power supply. Okay, so this is a basic requirement. This is a minimum requirement that we needed. You don't have to connect to OSC1 and OSC2, that is external oscillator, because this particular microcontroller has the capability of internal oscillator as well. So you can utilize them, or you can still mount your external resonator as well. Okay. All right, now let us move to the next section of the circuit design, which we will be talking about, you know, like different peripherals connection. So what I have done is I have connected some push buttons. So let us say push button S6 and S7. These two push buttons are connected to user PB0 and user PB1. Okay, so this user PB